Okay, so in this video we're going to do our MA268 Algebra 3's Week 2 question 4 on cosets. So it gives us a set H is equal to pairs of integers that sum to 0 mod 3, or just divisible by 3. And the reason they don't just put divisible by 3 is because they want us to use this as a hint, probably. Anyway, so we're given some cosets of this. So obviously we assume the fact that this is an additive, that Z2 is an additive group, and H is a coset. And so we have these other cosets, and we have to show that, first of all, we have to show that two of these cosets are equal. Plus H. Okay, so this, I mean, it might be possible to see right away which two are equal, right? I mean, one way you can do it is you can subtract them, right? And then you see you get an element in H, right? Subtract two of them and you see whether or not you get an element in H. So if you the answer is these two. So if you subtract this from this, so just subtract the whole cosets, right? So if you subtract it, like, use the rule that A plus H, this coset minus, B minus A, it doesn't matter, but I prefer it this way, is equal to B minus A plus H, right? And if you use that, you see that this is a sum. Okay. Actually, you can subtract it as well, it doesn't matter. The subtract is actually more useful in this case, although it's the same. Anyway, so if you subtract these two, you get minus 1. So subtracting this one from this one, you get minus plus H, right? But this is minus 1 1. It adds to 0, and 0 is 0 mod 3. So this is just a set H itself. So we have these two are equal. Okay, but that's a really shite way of doing it, right? That's a way where, as a mechanical way, right? You can check each one individually and see if this is in H, in which case you can just absorb it in. But the other way to do it would be just to notice that the different cosets would be x plus y adding to different things modulo 3, right? So this would be a coset that corresponds to this being a 2, right? So this would be a 2. This would be a 3, but we can also just reduce 3 to 0 because it's modulo 3. And this would be 0 as well. And thinking about it this way, right, you can tell that two of these cosets are distinct, right? These two are distinct, these two are distinct, right? And so that actually answers the second question. So this is so one I would be these two are equal, which we can, now we can clearly see these two are equal, right? So let's just call this 1, this 2, and 3 with an underline or something, just to show, or maybe a circle around. And so we have that 2 is equal to 3. We have that. Okay, we have that. That answers question 1. Question 2, it wants two distinct ones, but then number 2 is not equal to number 1. Right, these two are different because these two add to different things modulo 3. Okay, now the final question is, write down without proof third coset. So now we've got 0 and you've got 2. The only other number modulo 3 is 1. So we just want a coset where the two numbers add to 1. And so we can just pick this one. And so we're done. And so this answers question 4. So I hope that made sense. See you next one.